Hi, everyone. Welcome to Database Security Office Hours for January 2021. Today's topic is really actually a great one. We're going to be taking a look at the latest version of Oracle Key Vault. We released Key Vault version 21 just a week ago, so you are seeing it hot off the presses. And I'm very happy today to be joined today by the product manager for Key Vault and as well as Transparent Data Encryption, Peter Wall. Before we dig into Key Vault, though, just a couple of announcements. First, we are recording this and the recording should be available on the AskTom website, usually within a few days after the session is over. We do these every month. We've been doing them the second Thursday of each month. We're considering moving this to Wednesday for next month. We'll keep you up to date on the AskTom website as we make that decision. During the session, please feel free to enter questions at any time on any database security topic in the Q&A panel. You should see that at the bottom of your screen. And again, on any topic at all around database security, and we'll try and get you an answer. And now onto those announcements. In addition to Key Vault 21, we also released Database 21 recently, just a few weeks ago. That is available right now for autonomous database and for database systems. There are a ton of new features in Database 21. Probably one of my favorite is gradual database password rollover. This is a solution to a problem that we've had, forever, as long as I can remember as a DBA, where if you have an application that has an application server that is connecting to the database using some credentials, and if you want to rotate those credentials, because a lot of us have policies that say we should change passwords frequently or on some periodicity, that would always require application downtime in order to actually be able to change the password on the database and then go around and change it on all of the application servers that connect to the database. So there's always a little bit of downtime there. With gradual database password rollover, you now have the ability to set a new parameter in the user's profile called password rollover time. And what this parameter does is it gives you a grace period between the time the password is changed and the time that the old password actually starts working. For a brief period of time, whatever you set this parameter to, both the old and new passwords will continue to work. The idea is that if you use this parameter on password profiles that are assigned to service accounts where you need to have time to go out and change passwords in application servers, this will allow you to do that now without requiring any downtime at all in the application. So look for that in Database 21C. Another great new feature in 21C is the ability to set a default encryption algorithm at the database level. Up until 21C, if you create a table space and you don't specify an encryption algorithm, we would use the standard default, which is AES 128. Well, a lot of people have a different standard. They want their encryption to be AES 192 or AES 256. If you had created the database with the wrong encryption algorithm before, you would either have to convert that, which is time consuming and chews up a lot of resources, or drop the table space and recreate it. Now, you set a default encryption algorithm for the database and create your table spaces, and you will always be using your default, the default that you want to use instead of just the one that we set. We've got a couple of changes in Database Vault for 21C. We've added the ability to set command rules on administer key management controls. We've also improved the usability of Database Vault from an administration standpoint. Database Vault no longer has to be disabled in containers during upgrades. You simply assign the upgrade role to Database Vault, and you're able to do the upgrade without requiring any downtime or any extra work inside of the pluggable databases. One of the things you may have noticed if you're using Transparent Data Encryption, and this is something I have to give Peter Wall credit for, is a while ago, we began moving away from using the SQLnet.aura to define the encryption wallet location. And assigning that a database parameter. That has solved a ton of issues with people who would maybe start the database one time with TNS admin set to a certain location, start it another time without TNS admin set, or start it with server manager instead of SQL+. And what we would find is, without the environment variable set the right way, sometimes the database would try to be started with the wrong encryption wallet. Had the same types of issues with CMU that were compounded by the fact that at the pluggable database level, the default location for the wallet includes the PDB GUID, not the PDB name, but the actual PDB GUID. We've now solved that for you by adding a new parameter, CMU wallet, where you have explicit control over where your wallet is located. There's no more guessing where it's going to be. Lots and lots of other new features, improvements in unified auditing. A big new feature is kind of relating to today's topic. If you're upgrading Key Vault with 21C, you no longer require endpoint downtime. In previous versions, to upgrade the Key Vault and upgrade the endpoint couldn't be functioning. Now we allow you to dynamically load the PKCS11 libraries at the database level, which means you can upgrade that endpoint out from under the database without the database ever requiring a second's downtime. So really just tons and tons of great stuff. Now this is all for 21C, and one thing to keep in mind is that 21C is what we call an innovation release. That means that it is out now, but it will only be supported for about 2 years. Our long-term release is 19C, and 19C is the release we expect most of you to be going to. Over the upcoming months, we'll be looking at what features in 21C we might be able to backport to 19C. Stay tuned to the Database Security Office Hours, and we'll give you more information on that as we get more clarity. But 19C is still your long-term release. Okay. Another product update I want to fill you in on is around DataSafe. There's always changes in DataSafe. It's a very fast-moving product because it's a cloud service. Here's what's new since the last Ask Tom session. DataSafe is now available during OCI free trials. So for the length of your free trial, you are now able to consume DataSafe. There are some limitations on that. You are limited to one on-premises database target, and that can either be truly on-premises or it could be a database that's running in Azure or Amazon. The on-premises connector, which we've talked about for a while here at the office hours, is no longer in limited availability. That is now generally available. So if you have been wanting to try it out and didn't want to go through the trouble of getting into the limited availability program, you can do that now. There's nothing else you need to do. It'll just show up there on your user interface. And a really, really nice thing is we now have DataSafe available in Oracle Live Labs. So if you want to play with DataSafe in a guided fashion where you get to exercise all of the features, if you go to Live Labs and search for DataSafe, you get a great walkthrough of the product. Or if you have friends or maybe you're part of a user group and you'd like them to have a chance to try it, the combination of DataSafe available in Live Labs and DataSafe working with free trial editions means this has never been easier to do. Okay, a question just came in. Why would we call this 21C instead of 20C? Because we released Key Vault in this year, so the year is 21. Okay. Let's see, with the changes to Key Vault and the new version of the database, we do have some new documentation out there. For database 21C, that is now the default database when you go to docs.oracle.com and click into database. So if you want an earlier version, you'll have to use the drop-down list to select something like 19C, for example. There's a new manual that I'd like to call your attention to. It's called Learning Database New Features. And in that manual is a section for security. So really good chance to get more in depth in what those new features are. For Key Vault 21, of course, a new documentation set. And in this version, there are 2 new guides. One of those is the RESTful Services Administrator's Guide. The other is a guide devoted to the software development kit, which is both Java and C. Some of you like to download the PDF versions of these guides and keep them for reference. Just a recommendation, we're still making updates to both the admin and the RESTful Services guides. We're adding in new examples. There's lots of stuff with a new release, and those guides will be in flux for the next couple of months. So I would encourage you to use the online HTML version instead of the PDF version, at least for the next few months. And that is it for announcements. I'm going to go ahead and turn it over to the main presenter for today, who's Peter Wall. Again, for those of you who don't know him, Peter Wall is the father of Transparent Data Encryption. He's been at Oracle, I believe, over 25 years. He specifically manages both the Transparent Data Encryption feature and Oracle Key Vault. Peter, take it away.
Thank you, Russ, and thank you for reminding me of my age. Okay, welcome everyone. I hope that you can hear me well. I would like to introduce OKV 21 to you today, which was released a week ago. And so that's a quick overview of what Key Vault can do. You know that Key Vault is basically a purpose-built to provide key management for Oracle TDE-enabled databases. And if we start from the right and turn left, we do online key management for ACF as volume encryption keys. We can store the Solaris crypto keys in OKV, and the operating system can grab them when they're needed. Another feature that only OKV can do is we provide online key management for Golden Gate trail files. There's one extra benefit of this. This is not limited to the Oracle database only, because regardless of what database Golden Gate creates trail files from, we can encrypt them. And I mean, a Golden Gate can encrypt them, and OKV provides key management for those encrypted trail files. So this is a solution that is independent of the database vendor. We also provide online key management for MySQL databases, for Mongo databases. If you put your database backups into ZDLRA and you would like to instantiate from this backup a database in the Oracle Cloud, this backup will be encrypted and the keys are stored in OKV. The topic for today, though, is secrets management. That's a new topic, and OKV has a few nice features to offer that I would like to show to you today. On the left-hand side, you see two red entries under the database deployments, and I'm specifically proud to say that OKV has been certified to be used with Exadata Cloud at customer, and with the autonomous database on Exadata Cloud at customer. Those are the use cases. You may know that with Oracle 18, we introduced the clustering capability that is depicted in the little 4-node cluster in the middle of this page. You can put up to 16 OKV nodes into one cluster, and that basically provides unlimited key availability to all your database. The cluster is deployed in read-write pairs. This is between the nodes where you have this red arrow, and asynchronous synchronization between those pairs, and that's the green arrows. So whatever you do in your database, the database will connect to any one of those 16 servers, and whatever you do, if you do a set key, a rekey operation, your database prompt will only come back after the key material has been replicated to at least one more OKV. So whatever happens to your OKV cluster, we always have at minimum 2 copies of an encryption key. So if one of your OKV nodes goes down, it's not such a big catastrophe as it was before, because the database will find another OKV which has the same key it needs. So this is one of the benefits of clustering. Why is OKV the best and the only supported key management solution for TDE? So I mentioned this earlier. OKV has been purpose-built for the Oracle database. Right? If you have a rack-enabled data guard, a database with multi-tenant, that's the worst-case scenario for HSMs. OKV has been built for this, and we support all the gymnastics that you do with such a database. So if you do role switches, if you relocate your PDBs, even across containers, OKV is flexible enough to allow the encryption keys that belong to this relocating PDB to travel with the PDB from one container to the other. As I said earlier, we provide key management for encrypted Golden Gate files, and this is independent of the database vendor. And we provide secure and controlled sharing of keys. So if I need multiple databases to have access to the same key material, I can do this very easily by combining the endpoints that correspond to each database and combine them either with an endpoint group or make all create a wallet and make this wallet the default wallet for all those endpoints. That enables sharing of keys between those endpoints. In terms of scalability, I would say that OKV is unbeatable. We have several customers in the financial industry that are on their way to onboard 10,000s of databases into OKV clusters. And even Oracle itself, in the Oracle Cloud Infrastructure, we have a group that provides database service to the global business units, one of our fastest growing OCI customers. And they provide, currently they have roughly 12,000 databases managed in OKV clusters. They have deployed OKV in OCI with 8-node OKV clusters. They span regions with these clusters, so the keys are really available everywhere. In terms of security, it's virtually impossible to lose keys or secrets once they have been uploaded into OKV. First, the key material and the secrets are replicated to all participating nodes in the cluster, and everything becomes part of a regularly scheduled backup. So even if you lose your entire OKV cluster, you can use that backup, rebuild your first OKV node, and rebuild the entire cluster from this one node, and nothing will be lost. In terms of clustering, as I said earlier, you can put up to 16 OKV nodes in a cluster. Ideally, you would stretch those read-write nodes across your on-premise data centers. You can stretch those clusters from on-prem into OCI. So there are really there are many ways on how to deploy a keyword cluster. Okay, so what's new in OKV 21? We have a new user interface, which is really fast, and it's basically designed for huge deployments with hundreds of wallets, thousands of endpoints, 10,000s of keys and secrets. And we also have new use cases. That is why we're here today, right? We will be talking about secrets management. And because we keep adding new features into OKV, we improve the total cost of ownership. It's not that OKV becomes cheaper, but the price you pay, you get more and more features. And we also strive to make it more secure every time we make a change to it. So on your right, you see a screenshot of the new OKV homepage, which gives you an overview of how your cluster looks like. How many keys, how many secrets, how many wallets, endpoints, it's all there right on your first glimpse. And if you like to go to reports, you just click on that circle that belongs to the TDE master keys, and that takes you to the reports, and you're right there. So there's no longer the need to navigate via several pages and have them loading slowly. If you have thousands of keys, that may take a little while, or if you have lots of wallets, also that takes a moment. Those pages are loading really fast. So that's a huge improvement. And as I said, the steps to navigate to a useful thing that you want to do has been greatly simplified. So we basically provide shortcuts to simplify common use cases. It's optimized for large deployments, and it doesn't really matter on which device you look at these OKV pages. I tried it on my phone, on a tablet, on a laptop computer. They always look nice. They resize automatically. And yeah, as I said, we have the dashboard. We have new dashboards that allow you to drill down very quickly and see what's going on in OKV. And I believe the next slide tells me to show this to you live. Exactly. So let me log in as a REST admin user who has the system and key admin privileges And so this is a new installed OKV. I have only 8 master keys, but if I click on this, then it takes me to the report page immediately, and I see exactly to what database my keys belong, when they were created, a deactivation date, everything is right there. And if I close this button, then it takes me to the reports homepage, where I can drill down to system reports. I can see what my users are doing. I can see what the endpoints are doing, what about my secrets, my keys and wallets, and we have detailed reports about endpoint activity. So it's right there. And as you may have noticed, that the pages load much faster than with the older OKV versions. Okay, so today we talk about secrets management. There are multiple vendors out there that tell you that they can do secrets management, but what are you doing with those secrets? And first of all, what are secrets? Right? If you ask 5 people, you get 6 different answers of what is a secret. If you explain this from the other viewpoint, you say everything that I don't want you to know is my secret. A secret to me, or sensitive, or I don't want to give it away, it's private. There can be so many different things, right? Access control information, passwords, account numbers, whatever you hold dear to you is a secret. And so those can be many different things, but if you combine it that way, it makes the definition much easier. So how do we enable secrets management in OKV? We have completely restructured and enhanced the RESTful API for fetching and managing endpoints. So in the old OKV 18 RESTful services, that was really helpful to onboard TDE-enabled databases into OKV without the OKV administrators needing to do anything. It was a self-service, lights-out, automated approach to onboard encrypted databases into OKV. What we also could do, we could do KMIP operations, which means that we already had the baby steps to do secrets management. Now here, with the newly redesigned RESTful API, plus the C and the Java SDK, which has finally been released, we can fully jump into secrets management, and I will show you a little demo in a couple minutes. Now, when you broaden your deployment of OKV agents, you don't want an endpoint in your database that provides key management for your TDE database to somehow interfere with an endpoint that provides secrets management. So you need multiple endpoints on your server. You have one endpoint for TDE, you have another endpoint installed for encrypted ACFS, you have another endpoint for secrets management. No longer does the RESTful user who logs into OKV to onboard a database need the key admin and system admin privileges. So this is now a low privileged user that only has a create endpoint privilege. And so if you onboard your database, this is no longer an admin task in OKV. It's done by more of a DBA role, right? So that gives you dedicated ownership of a certain set of databases in OKV, to which databases we provide key management. So if I have 5 databases and I run this script to onboard those databases into OCI, then afterwards you will see that Peter owns those 5 databases in OKV, and when Russ onboards 10 databases, then you will see that those databases are managed by an endpoint administrator, Russ. That is how we get to isolated endpoint administration. And I'm also able, with the new RESTful services, to define a profile which allows me to manage multiple different endpoints with the same RESTful API. So I download the RESTful API only once, and by applying profiles, I can issue commands that modify the endpoint for TDE. I can issue a command that modifies the endpoint for secrets management, depending on which profile I use. So, and what are the use cases for secrets management in OKV? I mean, storing secrets is fine, but how do you actively use those secrets? So a couple of use cases, and the first one is what I will be showing you later, is that if you have automation scripts in your database to refresh a data warehouse, to run an RMAN backup, to refresh materialized views, to rebuild indexes, stuff that runs every night, every week, those scripts need a database account, username and password. Ideally, you don't have that password in clear text. You put it into a secure external password store, which is an auto-open wallet on your database machine. You can instruct the database to retrieve that password for this user from the auto-open wallet. Now, if you change your password, you have to update all those wallets. And the wallets can be corrupted. They can get lost by mistake. And then your script cannot log in, and everything falls apart. So if you upload this password into OKV, first, you cannot lose it anymore because it's part of your backup. It's replicated inside the OKV cluster, and it's easy to share this password. So if you do fleet management with your databases, you most likely have an RMAN backup running on every database. And maybe you use the same user account to log in to each of these databases and do the RMAN backup. So now you define this password once, and every database that needs that password gets an endpoint installed, and the endpoint of that database that needs access to the shared wallet will be combined with the database that shares the password, either with a endpoint group or with a default wallet. So that is how you can control shared keys. And this is one RESTful command to enable or disable sharing, either for all connected databases or for individual databases. So if your database gets under attack, if you notice something is wrong with my RMAN backup, somebody is misusing this account, then you can easily cut off the password from that database endpoint, and your RMAN script no longer logs in. There is a special use case if you create encrypted RMAN backups. I'm sure you know that in RMAN you have 3 different possibilities to create encrypted RMAN backups. One is called transparent, where RMAN uses the master key of your source database to encrypt the RMAN backup. And the second way of doing this is by specifying password, which encrypts the RMAN backup with a password. So if I would like to share my encrypted RMAN backup with somebody else without giving him my encryption keys, I can share this backup with a password. So now this password can be put into OKV, and the RMAN script can get this password out of OKV when it needs to log into the database. Now, if I put the database where I run the RMAN backup and the database where the RMAN backup is restored to, both in OKV, and let them share that same wallet, give them access to that shared wallet, then I don't need to worry about that password anymore. Both databases have access to it, and I can update that password centrally. To another use case is that most likely you're using public key authentication to get into your remote servers. If you look at compute instances in OCI, passwords don't work. The only way to get in is you have to upload your public key when you create your database or your compute instance, and then you present your private key when you log in. Right? Your private key, as the name implies, points to you. So if I get hold of your private key and do silly things, then the evidence points to you, not to me. So this is one reason why we want to keep those private keys really private. And you could upload that private key into OKV. And when you log into your remote server, you write a script that retrieves the private key from OKV and presents it to the remote server and allows you to log in. The DBMS crypto package that is frequently used to encrypt on the application level has a documented weakness. It doesn't provide key management. So key management was one of the tasks that the application developer or the developer who wrote this encrypt and decrypt statements to somehow make sure the keys are not lost, are secure from being stolen or compromised. So now with secrets management and with the C and Java SDK, you can add a couple lines to your code, and DBMS Crypto will retrieve the key to decrypt or encrypt a string from OKV. So finally, we have key management for DBMS crypto after like 20 years or something. Here you see a terminal window of my database. And there we will do secrets management. So the first thing that I will be doing is I will create a new directory that holds the new endpoint, right? I already have an endpoint that provides key management. This database is fully encrypted already. So now I create a new directory for an endpoint. And I create an endpoint in OKV. I do this with the new RESTful services. And you know, the syntax is different, but there are a few items that are familiar. We have an endpoint name. Those endpoint names can be really long now. We have a description. We have a type. This is Oracle non-DB because it's not a database. We do secrets management here. It's not a unique wallet. I could have picked unique and my platform. So this is no rocket science. And so now I'm creating an endpoint, a new endpoint in OKV. This is when you do demos a couple of times. Let me quickly fix this. I would have sworn that I cleaned up. Let me show you that I'm not faking it. So everything is live here. Endpoints, and there is an endpoint from last night. So let me delete this one. Okay, so now the endpoint is deleted, and I will rerun the statement, and I can create my endpoint. Okay, so now we have an endpoint. The next step is I will be provisioning, meaning download and install the endpoint. Right, this is my endpoint name so that we know which one. And here is the installation directory. This is the directory that I created up here. And it's an auto login wallet because, well, if you do secrets management, you don't want to be prompted for an OKV password all the time. That is why we put an auto login wallet there. So now let's create a password that we will, in a few seconds, upload into OKV. So this is a random password. Let's take a look how the password looks like. That's a password. Very nice. So now we log into my PDB and create a user that is with the name refresh data warehouse, because that's what the user does every night, and we use that password. Okay, and because we are security people for this demo, we only allow that user to connect to the database, nothing else. So now that I have created the user and defined the password, I will upload that password into OKV. For this, I need to make changes to a JSON document. So let me create this document first, and then we go check it out. This contains everything, all the options. So here I need the object that I'm uploading is my password file. That's my file. This is a password. The mask cannot be empty, so we just leave the encrypt mask in there. Everything else goes. We don't need a wallet in this case, and we don't have contact info. We only have a name. This also have to, this goes, and the name of my user was refresh data warehouse. Refresh data warehouse. Okay, no typos. Okay, let's save this and execute the JSON script. So here, at first we said create JSON input, and now we say from JSON. Oh, what happened? The file is called refresh password, not refresh data warehouse. That's the problem. Okay, so we put this into a file called refresh password. Yes, of course. Okay, so let's try this again. Okay, so now I uploaded the password into OKB. This is my KMIP ID that uniquely identifies this password. If you ever forget this unique ID, if, let's say, after 6 months the password expires, you would like to deactivate it, destroy it, you need this KMIP ID. If you forgot the KMIP ID, then you can get this KMIP ID back by just simply searching for the name that we added into the JSON file. So this allows me to retrieve the unique ID. Before I can use it, we first would like to delete the password file from my hard drive, and then I will activate the secret. So this is the activate command, and I need the KMIP ID here. Okay, so now the secret is activated, and you notice that I started using profiles at one point. Right? When I created the endpoint, when I provisioned the endpoint, I still used my low-privileged user. But for key management operations, I need a key manager in OKV. So here I choose a different profile called secrets. And this is defined by the way the activation was successful. The profile is defined in a configuration file. So this is my default. This is what I needed, or what I used to onboard my encrypted database into OKV. Now all the strings here, OKV client config, replaces this entry, and the username replaces this entry. And so now I'm using a different configuration file that is specific to my new endpoint. And I'm using a user in OKV that has the key administrator privilege. So this is how I can use the same RESTful services to manage multiple endpoints. So now in order to log in, I need a quick script. Oh, there we go, it's already there. So this script uses the RESTful services to locate, to find the KMIP ID. We have done this before, so we are searching by a username. And afterwards, we get the secret, which is the password, by applying the KMIP ID here, right? And then I make a few choices depending on how my connect string looks like, to either log in as RMAN with the sysbackup privilege, or as a normal user here. So that's a very simple script. And if we need to make this executable first, like this, and then we run the script and try to connect as the user refresh data warehouse. That's the username. This is my connect string into my PDB, and then I retrieve the password from OKV. Right, so now I'm connected as refresh data warehouse to my pluggable database. So that concludes my demo. Okay, so how do we reduce the total cost of ownership and improve security? I mentioned earlier that we now have low privileged users that can onboard TDE-enabled databases in OKV. Both the endpoint administrators and the well-known keyword administrators that we always had, the sysadmin, key admin, and the auditor roles in OKV, all of them can be managed centrally in Active Directory. Right, so this is really important if you have a large OKV cluster, 16 nodes, or multiple smaller clusters, and one of your endpoint administrators leaves the company, so you want to retire that account quickly. So it's my understanding that you can remove or disable the account in Active Directory, and then those people can no longer, that account can no longer be used to log into OKV. The RESTful services has been extended, and we talked about this already. So instead of only allowing onboarding of TDE-enabled databases, we do key and secrets management. We allow to monitor OKV using the RESTful services. You can schedule and set up regular backups. You can define external backup locations. All is scripted. And so this is much more powerful than it was before. We added the SFTP transport protocol to our remote backup locations. So now, in the older versions, you only could use SCP to copy a backup to an external file system. Now you can use SFTP, which allows you, among other targets, to define a ZFS storage appliance as a backup destination to OKV. We upgraded the appliance. We upgraded to database 19 from 18. We upgraded from Oracle Linux 6 to Linux 7. And we also allow you to put in 2 network cards, both with the same IP address. They are in active passive mode. If the active network card retires from service, then the other network card will take over. So that's another aspect of us trying to make the system as highly available as we can. One word to the upgrade process. If you upgrade from OKV 12 to 21, you most likely have an active passive setup. For this case, there will be downtime from a server perspective, but you can use the persistent cache on your database servers to keep the databases running even if the OKV servers disappear from the network for a while. If you upgrade an OKV 18 cluster to a 21 cluster and you have at least 4 nodes, then you can upgrade this entire cluster without database downtime. You even have full read and write access into the cluster all the time. So that's an important aspect, that even upgrades, and those are big upgrades, right? That you can do those without service interruptions to your database.
So it was really great. One of the questions that came in while Peter was going over the user interface was, does Key Vault 21 work with Active Directory? And that's what I'm going to show you. Yes, it absolutely does. I'm going to do this as a walkthrough rather than live. And the reason I'm doing that is just in the interest of time, where we've only got about 15 minutes left and we want to leave some time for questions at the end. We're first going to log in. So I'll log in as a user who has the system administration privileges. When I go in through system administration, I'll first click on users, and we can see that currently all we have are local users. Users who are defined within Key Vault. From here, I'll go to the System tab, and I'll click Settings. In Settings, over on the right-hand side, you'll see Network Services. I'm going to click LDAP. And because I don't have a LDAP configuration right now, I'm going to click Add to add that LDAP configuration. I have to fill out the configuration, and here's what I'm telling it. I give it an arbitrary name, that's the configuration name. In this case, I've chosen to use the domain name as the name of the configuration. I didn't have to do that. The only directory type we support right now is Microsoft Active Directory, so I'll leave that selected. And I will put in a username within Active Directory to connect as. I've created a special service account in Active Directory called OKV User. This account doesn't have any privileges other than normal domain user membership, so no special groups, no administrator privileges required. I'm just OKV User. I give it my password, and I tell OKV where the domain controller is. I did not have DNS set up on this particular system, so I gave it an actual IP address. If I did have DNS set up, I would probably just use the DNS alias for the domain so that I could load balance across all of the domain controllers. This next part is really important. My domain controllers have to be configured for TLS. They have to accept a secure LDAP connection. If you have already configured CMU, your domain controllers have already done that. If you have anything non-Microsoft integrated with Active Directory, you probably already have TLS set up for your LDAP servers. But if you haven't, you're going to have to go through those steps first. So your port is the secure port 636, and you will give it the trusted certificate that Active Directory used for that TLS connection. Again, if you have CMU set up, this is the exact same trusted certificate you use to set up CMU. Next, you just give it the domain name and you tell it where within the domain to search for users. I've left it at the root of the domain because my users can be spread across multiple organizational units. The last part is the defunct LDAP user's grace period. We kind of struggled with the name on this one, but basically what we're doing here is every time an LDAP user logs in to Key Vault, a profile is created within Key Vault. Key Vault periodically checks those profiles to make sure they're valid, and then if they're not valid, discards them after whatever you have set here, number of days. Okay, you'll see that profile in just a second, by the way. I click test connection. I got it right. So the next thing I'm going to do is click save, or add rather, and I now have a LDAP configuration ready to be used, but I'm not quite done yet. I have to log out now because my session wasn't aware of the Active Directory configuration because it didn't exist when I logged in. So I go back to my login screen and notice that my login screen has changed. I now have this new little square box where you see local. When I click into that box, I have a choice. I can have a local user or a domain user. I'm still going to be local because I haven't finished configuring Active Directory yet. And this time I'm going to log in as a user with the Key Vault or key administration privilege. I log in as key admin, and this time I'll go to users and I'll click Manage LDAP Mappings. On Manage LDAP Mappings, I'm going to click Create, and only a user with the Key Vault admin privileges can create an LDAP mapping. Okay, so I'll click Create, and I will search for the group I want. I had pre-created in Active Directory 3 groups. One of them was called OKV Admin, one of them was called OKV Auditor, one of them OKV System. Those names are arbitrary. I could have used any name I wanted to. I'll select the OKV Admin group, and the reason I'm selecting the OKV Admin group is I'm logged in as Key Vault Admin. Key Vault Admin cannot grant a group that he is not a member of. So I can't grant the key or the system administrator role to a group because I'm not a member of the system administrator role. I can't grant the Key Vault Auditor role to a group because I'm not a member of that. So I'll create the group, and I will click Create, and that's all there is to it. Now, if a user logs into Key Vault from Active Directory who happens to be a member of that Key Vault admin group, when they log into Key Vault, they will now have the key admin role. But I want to go a little bit further. So now I've logged out and I've logged back in as a user who has both the system administrator role and the key admin role, Russ in this case. Because I have both of these, I can now grant both of these roles. So I'll map Key Vault System group to System Administrator. And you can see I now have 2 mappings. I would repeat that process with someone who has the auditor role. If you don't have any users that have multiple roles, Key Vault Admin can create a mapping and just not assign a role to it. And a user with Key Vault System role, System Administrator role, or Auditor role can edit a mapping. They just can't create a mapping. Okay, so I log back out, and this time I'm going to log in and I'll select DBSec Labs, and I'll log in using my standard Active Directory username, in my case R. Lowenth, and my standard Active Directory password, which is Oracle is the greatest thing you've ever seen. That's been my password forever, by the way. I'm logged in. You can see I'm now logged in as R. Lowenth. And if I click the little drop down next to my name, I can see my distinguished name in Active Directory. I can see the domain controller that I logged in as, or the configuration, the LDAP configuration that was used. If I click on users, notice down at the very bottom of the screen, you'll see a profile was created for me. This didn't exist before. If I click into that profile, I get more information. Again, I see my distinguished name. I see the full name that was retrieved from Active Directory, which LDAP configuration was used, which Key Vault roles I have, Key Administrator and System Administrator, and down at the bottom, which Active Directory groups I'm a member of that relate to Key Vault. That is all there is to it. Setting this up just takes minutes to do. There are 3 things I want you to remember for the Active Directory integration. The first is you have to configure Active Directory for TLS. This will not work if you don't have the ability to make an LDAP-S connection to Active Directory. when you ask the domain administrator for the trusted root certificate, same as for centrally managed users, you want to ask for that certificate in base 64 format. If you get it in PEM format, that's a binary format and you won't be able to put it into the system. So get that trusted root certificate in base 64. Only a user with the key vault, with the key admin role can create LDAP mappings. So Key Vault system, Key Vault auditor, they cannot create the mappings. You cannot map a Key Vault role to an LDAP group unless you have that role. So Key Vault admin can't map Key Vault system or Key Vault auditor, okay? And that's it. If you remember those three things, you're golden, and you will very quickly be up and running with Active Directory integration for your Key Vault system. Peter, I'm going to turn it back over to you.
Yes, of course. Thank you. So if you forget everything that we talked about, here are the things that you should remember when you leave this meeting. Oracle Key Vault is the preferred and only supported by Oracle supported solution to do TDE key management. It's highly scalable and highly available, and it prevents loss of keys, which is very painful, by the way, and there's no backdoor. So if you lose your wallet, there's no need to call Oracle. There's nothing we can do. And so this putting your keys into OKV helps to avoid the lost key problem. We spread into many items in the Oracle ecosystem, as you can see, and this list will be growing over the next couple of months. With OKV 21, we expand use cases to provide secrets management on an enterprise level with simplified sharing of secrets, and also of very simple disabling of secrets, which means you disable your endpoint to get this password if the need be. By adding in all these new features into OKV 21, we didn't raise the price. It's still the same price, meaning your TCO becomes better and better with every version because we keep on adding features into it. If you would like to try it yourself, the link below points you to an OCI instance on the Oracle Marketplace. So you click 5 buttons and enter a little bit of information, a name and an IP address and your public key. And 15-20 minutes later, your OKV is running in your instance. If you do functional testing, then a VM standard 2.2 is big enough to give you a responsive demo system. What I would suggest is to either build a 2-node system in OCI where you have one node where you have both nodes in the same region but in different availability domains. And if you like to experiment with a larger cluster, then I would use a remote peering and stretch a read-write pair across regions. And then you can do your functional testing on a really, really strong scale. Okay, that's all from my side. Thank you.
And folks, one challenge, unless you're taking a screenshot, you may not be able to click that URL since it's in a Zoom meeting, but apologies for opening that browser on top of you, Peter. But if you want to get to that marketplace image, once you're logged into your tenancy, just scroll down to Marketplace, Applications, give it a second to finish loading. And if you search for Key Vault, this is where that image is. And one really great thing that Peter did in this version is he now has all of the versions in a single image. So there's no longer the requirement to go find which one of the multiple marketplace images you want to use. You can just select the version you want. And of course, you're going to want 21.1. All right. So again, thanks everyone. We hope to see you next month for Database Security Office Hours. We're tentatively planning those for Wednesday, the 10th of February. And our topic will be Audit Vault and Database Firewall 20.3. You may be saying, but wait, 20.3 isn't released yet. Well, by next month it will be, unless something really bad happens. In fact, with any luck, you'll either see at the end of this week or perhaps early next week. So we'll be talking about what's new in 20.3 and looking forward to seeing you all then. And with that, let's just take a quick review of questions.